Okay, shall I start?
Yes, sir.
Yes, sir.
Okay. Yes. Listen to me. If we pluck the stretched string exactly at the middle point, then there is a formation of only one loop. On the video ತೋರಿಸ್ತೀನಿ ಇದೊಂಚು explanation ಕೊಟ್ಟಾದ್ಮೇಲೆ hopefully ಅದು ಚೆನ್ನಾಗಿ play ಆಗುತ್ತೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ ನೋಡೋಣ. Okay, so it is not necessary that it has to vibrate in one loop. It can also vibrate in 2 loops, it can also vibrate in 3 loops, it can also vibrate in 4 loops, etc. ನಾವು ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅದನ್ನ ಪ್ಲಕ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ, ಸೊ ಆ ಸ್ಟ್ರಿಂಗ್ ಒಂದ್ ಲೂಪ್, 2 ಲೂಪ್, 3 ಲೂಪ್ಸ್ ಅಥವಾ 4 ಲೂಪ್ಸ್, 5 ಲೂಪ್ಸ್, ಎಷ್ಟು ಲೂಪ್ಸ್ ಆಗಾದ್ರೂ ಕೂಡ ವೈಬ್ರೇಟ್ ಆಗ್ಬೋದು. Anyhow, let us assume that we are plucking at the middle point. So if you pluck at the middle point, then actually it undergoes vibration into one segment or one loop. Okay, then this mode where the string is vibrating with one loop is what we call it as fundamental note. ಗೊತ್ತಾಯ್ತಾ ಇದು? ಗೊತ್ತಾಗ್ತಿದ್ಯಾ?
Yes, sir.
Okay, then if it is vibrating in fundamental note, then whole length, ಇಡೀ ಲೆಂತ್ ಒಳಗಡೆ ಒಂದೇ ಒಂದು ಲೂಪ್ ಇದೆ. Please remember, one loop means half of the wavelength. So therefore I can say that L is lambda by 2. Length of the loop L. ಆ ಇಡೀ ಲೆಂತ್ ಆಫ್ ದ ಲೂಪ್ ಒಳಗಡೆ ಒಂದೇ ಒಂದು ಲೂಪ್ ಫಾರ್ಮೇಶನ್ ಆಗಿದೆ, ಯಾಕಂದ್ರೆ ಅದು ಫಂಡಮೆಂಟಲ್ ನೋಟ್ ಅಲ್ಲಿ ವೈಬ್ರೇಷನ್ ಆಗ್ತಾ ಇದೆ. ಒಂದ್ ಲೂಪ್ ಅಂತಂದ್ರೆ ಹಾಫ್ ಆಫ್ ದ ವೇವ್ ಲೆಂತ್ ಆಗುತ್ತೆ, 2 ಲೂಪ್ ಆದ್ರೆ 2 times half of the ವೇವ್ ಲೆಂತ್ ಲ್ಯಾಂಬ್ಡಾ ಅಂತ ಆಗುತ್ತೆ. ನಾನು ಹೇಳ್ತೀನಿ ನಾನು. ಓಕೆ, anyhow, so if it is vibrating in fundamental note with one loop, then the length L is lambda by 2, where length is length of the string, L is lambda. Lambda is nothing but wavelength of the transverse wave. So where lambda is the wavelength of the wave. Okay, so then frequency of the fundamental note is given by, now please remember, frequency is given by V by lambda. Frequency, velocity is equal to frequency into wavelength adre, so frequency must be equal to velocity by lambda. Correct idea?
Yes, sir.
Okay, then velocity expression is square root of t by m, that we have already derived. Correct?
Yes, sir.
Then length L is equal to lambda by 2. ನಾನು ಬರ್ದಿಲ್ಲ, but L is lambda by 2 ಅಂತ ಸ್ಟೇಟ್ಮೆಂಟ್ ಎಲ್ಲ ಬರ್ದಿದ್ವಿ. L is equal to lambda by 2 ಆದ್ರೆ lambda becomes equal to 2L. Do you agree?
Yes, sir.
If L is equal to lambda by 2, length is equal to half of the wavelength lambda by 2 ಆಯ್ತು. So therefore lambda must be definitely equal to 2L. So therefore lambda generally 2L ಹಾಕಿದ್ದೀನಿ. So therefore frequency of the fundamental note is given by 1 by 2 lambda into square root of t by m. So this is what the expression for the frequency of the fundamental note. What do you mean by fundamental note? When the string is vibrating with one single loop. The diagram ತೋರಿಸ್ತೀನಿ ನಾನು, ಒಂದು video play ಮಾಡಿ ತೋರಿಸ್ತೀನಿ ನಾನು. So if it is vibrating with one single loop, then we say that the string is vibrating in the fundamental note. And what is the frequency of the fundamental note? Frequency of the fundamental note F is given by, so V by lambda, that is given by 1 by 2L into square root of t by m. Is this clear?
Yes, sir.
Okay, next we shall move. ನಾನು ಆಗ್ಲೇ ಹೇಳಿದೆ, so it is not necessary that the string should vibrate with only one loop. ಒಂದೇ ಲೂಪ್ ಅಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗಬೇಕು ಅಂತ ಯಾವ ರೂಲ್ಸ್ ಇಲ್ಲ. It can vibrate into 2 loops, it can vibrate into 3 loops, it can vibrate into 4 loops, it can vibrate into 5 loops, 6 loops, 7 loops, etc. ಪ್ರತಿ ಲೂಪ್ ಅಲ್ಲೂ ಕೂಡ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ 2 loops to 3 loops 4 loops ಅಂತ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋದ್ರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಯಾವ ತರ ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜ್ ಆಗುತ್ತೆ, that is what we are trying to understand here. Okay, so that is why we are calling it as harmonics and overtones. ಅದು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ತಲೆ ಕೆಡಿಸ್ಕೊಬೇಡಿ, ಇಲ್ಲಿ ಟೇಬಲ್ ನೋಡೋದು ಗೊತ್ತಾಗುತ್ತೆ. ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ದ ಟೇಬಲ್. ಲಾಸ್ಟ್ ಕಾಲಮ್ ನೋಡಿ, ನಂಬರ್ ಆಫ್ ಲೂಪ್ಸ್ 1 ಅಂತ ಇದೆ ಅಲ್ವಾ?
Yes, sir.
ಸರ್ ಮುಸ್ಲಿಮ್ರ ತರ ರಿವರ್ಸ್ ಓದ್ಕೊಂಡು ಹೋಗ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ. If it is vibrating with one single loop, then it is called a fundamental note. ಆಗ್ಲೇ ಹೇಳಿದೆ ಅಲ್ವಾ? This I have already explained. It is called, actually this is what we call it as overtone, and the first overtone is nothing but first fundamental note. Heading ನೋಡ್ಕೊಳ್ಳಿ, I have written the heading frequency, harmonics, overtone and number of loops ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಬಟ್ ಟೇಬಲ್ ನಾನು ನಿಮಗೆ ಓದ್ ಹೇಳ್ಬೇಕಾದ್ರೆ ರಿವರ್ಸ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ನಂಬರ್ ಆಫ್ ಲೂಪ್ಸ್ 1 ಇದ್ದಾಗ, so that overtone is what we call it as fundamental note. Or ಅದನ್ನ overtone ಅಂತ ಕರೆಯೋ ಬದಲು harmonics ಅಂತ ಕೂಡ ಕರಿತೀವಿ. It is called the first harmonic and the frequency is M. So let us assume that it is vibrating with two number of loops. ಯಾಕೆ ಒಂದು ಲೂಪ್ ಅಲ್ಲೇ ವೈಬ್ರೇಟ್ ಆಗಬೇಕು, ಟೂ ಲೂಪ್ಸ್ ಅಲ್ಲೂ ಕೂಡ ವೈಬ್ರೇಟ್ ಆಗೋ ತರ ಮಾಡಬಹುದು. ಟೂ ಲೂಪ್ಸ್ ಅಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗಿ ಮಾಡಿದ್ರೆ ದೆನ್ ಒಂದು ಲೂಪ್ ಅಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗೋ ಹಾಗೆ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಫಂಡಮೆಂಟಲ್ ನೋಟ್ ಅಂತ ಕರಿತೀವಿ. ಟೂ ಲೂಪ್ಸ್ ಅಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗೋ ಹಾಗೆ ಮಾಡಿದ್ರೆ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಫಸ್ಟ್ ಓವರ್ಟೋನ್. ಗೊತ್ತಾಗ್ತಿದೆಯಾ? ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಫಸ್ಟ್ ಓವರ್ಟೋನ್. If it is vibrating into three number of loops, it is called a second overtone. If it is vibrating with four number of loops, it is called a third overtone. Confusion ಮಾಡ್ಕೋಬೇಡಿ, ಇದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ತುಂಬಾ ಕೇರ್ಫುಲ್. ಅದಕ್ಕೆ ಟೇಬಲ್ ಹಾಕ್ಬಿಟ್ಟು ನಿಮ್ಗೆ ಗೊತ್ತಾಗಿಂತ ಆ ಮೋಡ್ ಇದೆಯಲ್ಲ, ಡಿಫರೆಂಟ್ ಮೋಡ್ಸ್ ನ ಓವರ್ಟೋನ್ ಅಂತಾನೂ ಕರಿತೀವಿ, ಜೊತೆಗೆ ಹಾರ್ಮೋನಿಕ್ಸ್ ಅಂತಾನೂ ಕೂಡ ಕರಿತೀವಿ. ಓವರ್ಟೋನ್ ಅಂತನಾದ್ರೂ ಕರಿಬಹುದು, ಹಾರ್ಮೋನಿಕ್ಸ್ ಅಂತನಾದ್ರೂ ಕರಿಬಹುದು. ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಓವರ್ಟೋನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಫಸ್ಟ್ ಓವರ್ಟೋನ್, ಸೆಕೆಂಡ್ ಓವರ್ಟೋನ್, ಥರ್ಡ್ ಓವರ್ಟೋನ್ ಅಥವಾ ಫಂಡಮೆಂಟಲ್ ನೋಟ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಆತರ ಕೇಳಲ್ಲ, ಓವರ್ಟೋನ್ ಕೇಳಲ್ಲ. ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾನೆ, ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಫಸ್ಟ್ ಹಾರ್ಮೋನಿಕ್, ಸೆಕೆಂಡ್ ಹಾರ್ಮೋನಿಕ್, ಥರ್ಡ್ ಹಾರ್ಮೋನಿಕ್, ಫೋರ್ತ್ ಹಾರ್ಮೋನಿಕ್ ಅಂತ ಕೇಳ್ತಾನೆ. ಸೊ ಹಾಗಾಗಿ ಎರಡನ್ನೂ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೀನಿ. ನಂಬರ್ ಆಫ್ ಲೂಪ್ 1 ಇದ್ರೆ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಫಂಡಮೆಂಟಲ್ ನೋಟ್, and it is also called the first harmonic, and frequency is here. If it is vibrating with two number of loops, then it is called the first overtone. First overtone and the fundamental note and be careful here. Fundamental note is the number of loops 1 irbeku. Number of loops eradidre it is called the first overtone. First overtone is same as second harmonic, and the frequency will be 2 times here. Fundamental f bandre, so first overtone athwa second harmonic 2f barutte. If it is vibrating with the 3 number of loops, then it is called a second overtone, or it is also called a third harmonic. Then the frequency is 3 times f. F is fundamental note frequency. If it is vibrating with 4 number of loops, so then it is called, we say that it is vibrating in third overtone, or it is also called a fourth harmonic. So the frequency is 4f. So in general, ನೋಡಿ ಕೆಳಗಡೆ ಬರ್ತಿದ್ದೀನಿ, if the string is vibrating with p number of loops, n ಅಂತಲ್ಲ p ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ, p number of loops, p may be 1, p may be 2, 3, 4, 5, 6 ಏನಾರು ಆಗಿರಬಹುದು, then the frequency is given by f dash is equal to p by 2n into square root of 2 by m. For example, p is equal to 1 ಹಾಕೋರೆ it becomes fundamental note or first overtone. So frequency f dash becomes the same as here. If you substitute p is equal to 2 here in expression 2, so then it becomes first overtone or second harmonic. Frequency is 2 times. If we substitute p is equal to 3, so then it is called second overtone, or it is also called as third harmonic. So the frequency is 3. If it is vibrating with 4 number of loops, and p is equal to 4 hakondre, then it is called a third overtone, or it is called a fourth harmonic. So the frequency is 4f. ಗೊತ್ತಾಯ್ತಾ ಇದು?
Yes sir.
ಇದನ್ನ ಯಾಕೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ? Can you see the screen?
Yes sir.
Can I give
Yes,
play?
sir.
Play ಕೊಡ್ಲಾ ನೋಡಿ, play ಕೊಡ್ತೀನಿ ನೋಡಿ, play ಆಗುತ್ತೆ ನೋಡಿ. Just observe. It is vibrating with one loop. Now it is vibrating with the 2 loops. Now 3. Now it is 4. Now 5 loops. Loop size ಚಿಕ್ಕದಾಗ್ತಾ ಇದೆ, but 5 loop ಕಾಣುತ್ತೆ. ನೋಡಿದ್ರ?
Yes sir. Yes sir.
Clear play ಆಯ್ತಾ?
Yes sir.
ಬೇಕಾದ್ರೆ ಇನ್ನೊಂದ್ಸಲ ನೋಡ್ತೀನಿ ಅಂದ್ರೆ ಬೇಕಾದ್ರೆ ಇನ್ನೊಂದ್ಸಲ ಪ್ಲೇ ಮಾಡ್ತೀನಿ. One more video. Mute ಮಾಡ್ಕೊಳ್ಳಿ. I hope you people were able to see.
Yes, sir.
Yeah, the first one was little clear. Second video some clarity irಲಿಲ್ಲ. I think first one ಅಲ್ಲಿ ಕೆಳಗಡೆ n is equal to 1, n is equal to 2, n is equal to 3 ಅಂತ ಬರ್ತಿತ್ತು. n is equal to 1 ಬಂದಾಗ just a second. Okay, background ಅಲ್ಲಿ ಏನೋ ಪ್ಲೇ ಆಗ್ತಿತ್ತು ತೆಗೆದೇ ಅದನ್ನ. Okay, I think n is equal to 1, 2, 3, 4 ಅಂತ ತೋರಿಸ್ತಿದ್ರು. n is equal to 1 ಅಂದ್ರೆ 1 ಲೂಪ್ ಅಲ್ಲಿ ವೈಬ್ರೇಷನ್ ಆಗ್ತಿತ್ತು, 2 ಅಂದ್ರೆ 2 ಲೂಪ್ಸ್ ಅಲ್ಲಿ ವೈಬ್ರೇಷನ್ ಆಗ್ತಿತ್ತು, 3 ಅಂದ್ರೆ 3 ಲೂಪ್ಸ್ ಅಲ್ಲಿ ವೈಬ್ರೇಷನ್ ಆಗ್ತಾ ಇತ್ತು ಅಲ್ವಾ?
Yes, sir.
Okay, so this is what we call them as modes of vibration. We call them as modes of vibration. These modes of vibration, they are either called harmonics or overtones. Overtones anta ಕೆಲವು ಸಲ ಕರಿತೀವಿ, ಕೆಲವು ಸಲ harmonics ಅಂತ ಕರಿತೀವಿ. This is all decided by the number of loops. If the number of loops are 1, 2, 3, 4, then they are called first harmonic, second harmonic, third harmonic, fourth harmonic, etc., etc. It is not necessary that we should always tell in terms of harmonics. We can also express in terms of overtones. If number of loops are 1, 2, 3, 4, then they are actually respectively called fundamental note, first overtone, second overtone, third overtone, etc., etc., etc. Okay, whatever may be the overtone or whatever may be the harmonics, so the frequency of the vibrating loop is given by f dash is equal to p by 2l into square root of t by m, where p is nothing but number of loops. Number of loops 1, 2, 3 ಏನಾದರೂ ಹಾಕೊಳ್ಳಿ, then you are going to get the respective frequency. For example, if I substitute p is equal to 3, I am going to get an expression like 3 by 2l into square root of 2 by m. So that actually n is equal to 3, sorry, p is equal to 3 is either called second overtone or it is also called third harmonics. Okay, na? And third harmonics has a frequency which is actually 3 times that of the fundamental frequency. Fundamental frequency, if first harmonic frequency f anta barkondre, second harmonic to 2f ಬರುತ್ತೆ, third harmonic to 3f ಬರುತ್ತೆ, fourth harmonic to 4f ಬರುತ್ತೆ. ಅಥವಾ first overtone frequency is 2 times that of the fundamental frequency, second overtone has a frequency 3 times that of the fundamental frequency, and third overtone has a frequency which is actually 4 times that of the fundamental frequency. Okay, na?
Yes, sir.
Another topic, as per your syllabus, we want to understand the two types of velocities. There are two types of velocities associated with a wave. So the first one is what we call it as phase velocity, and the second one is what we call it as group velocity. Okay, this phase velocity we have already discussed, but anyhow, we wanted, for the sake of continuity, we want to discuss it once again. Okay, if you consider one wave, one simple harmonic wave, this I have already mentioned. So for a single simple harmonic wave, so the equation can be written as y is equal to a sin omega t minus x. ಇದನ್ನ ಆಗಲೇ ಮುಂಚೆ ಮೆನ್ಷನ್ ಮಾಡಿದೆ, ಜ್ಞಾಪಕ ಇದೆಯಲ್ಲ? When we derived differential equation of wave motion,
Yes, sir.
that time I mentioned that the single simple harmonic, one single means one, one single wave equation, simple harmonic wave equation is given by y is equal to a sin omega t minus kx, where omega is angular frequency, that is given by 2 pi f, f is frequency, k is called a propagation constant, and that is given by 2 pi by lambda, where lambda is the delta. Alva? Now, for this wave, phase velocity is given by phase velocity, and it is also called as wave velocity. They are one and the same. Phase velocity is same as wave velocity. So phase velocity or wave velocity Vp is given by simple. ಈ ಟಿ ಪಕ್ಕ ಏನಿದೆ ಒಮೆಗಾ ಇದೆ, ಅದನ್ನ ನ್ಯೂಮರೇಟರ್ ಬರ್ಕೊಂಡಿದ್ವಿ. ಎಕ್ಸ್ ಪಕ್ಕ ಕೆ ಇದೆ, ಅದನ್ನ ಡಿನಾಮಿನೇಟರ್ ಬರ್ಕೊಂಡಿದ್ವಿ. So phase velocity is simply given by the ratio of omega by k, where omega is the coefficient of t, k is the coefficient of x. ಇಲ್ಲ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದೆ, ನೆಗೆಟಿವ್ ಸೈನ್ ಸೇರಿಸ್ಕೋಬಾರ್ದು, ಅದನ್ನ ಪ್ಲಸ್ ಅಂತ ಹಾಕೋಬೇಕು. Now omega is angular frequency, it is given by 2 pi f, and k is propagation constant, it is 2 pi by lambda. 2 pi cancel agutte, lambda goes to numerator, so therefore it becomes f into lambda. So therefore phase velocity or wave velocity is given by Vp is equal to f lambda. So phase velocity or wave velocity is given by the product frequency into wavelength. How does it read?
Yes, sir.
Yeah, this I have told many number of times. I think this equation you might have seen in your PU classes also. So frequency velocity of the wave velocity, or it is also called phase velocity. From now onwards, I am going to use the word phase velocity. So phase velocity is simply given by the product of frequency into wavelength, f into lambda. So therefore, the expression for phase velocity is given by f into lambda. Okay, why we are calling it as phase velocity? Because so it is the velocity with which the phase of a wave travels forward. Okay, this omega t minus kx term, ಈ bracket ಅಲ್ಲಿ ಇದೆಯಲ್ಲ, ಈ y is equal to a sin omega t minus kx, this omega t minus kx term, this entire thing is what we call it as a phase ಅಂತ ಕರಿತೀವಿ. So the phase of a particle when a wave is traveling, so actually also travels. Wave travel ಆಗ್ತಾ ಆಗ್ತಾ wave ಜೊತೆ ಇರೋ phase ಅಥವಾ phase angle ಅಂತ ಕರಿತೀವಿ. Phase angle ಕೂಡ travel ಆಗ್ತಾ ಹೋಗುತ್ತೆ. The velocity with which the phase associated with the wave is traveling, so is what we call it as phase velocity. That's why we are calling it as phase velocity. Why we are calling it as phase velocity? Because it is the velocity with which the phase associated with the traverses. Okay, in a medium. On the medium ಅಲ್ಲಿ wave travel ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ ಆ wave in ಜೊತೆ ಇರೋ phase ಕೂಡ travel ಆಗುತ್ತೆ. Wave travel ಆಗೋದು ಅಥವಾ phase travel ಆಗೋದು ಎರಡು ಬೇರೆ ಬೇರೆ ಅನ್ಕೊಂಡ್ರಿ, both are same. That's why it is called phase velocity. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Now let us try to understand one more thing. This is last topic. Topic. So last topic is for today's session is what we want to understand, group velocity. So there is one more velocity associated with the waves. I am telling waves, not wave. Group velocity comes into picture when there are large number of waves. Phase velocity comes into picture when there is only single wave. Simple harmonic wave. If there is a single wave, velocities, phase velocity or wave velocity. If there are large number of waves traveling together, then no phase velocity iralla, but rather than phase velocity, it is a group velocity which we are interested. Okay, so here consider a group of waves with angular frequency and propagation constants varying continuously, superimposing on one another. The resultant wave pattern consists of points of maximum and minimum amplitude. This group of wave is what we call as wave packet, and the velocity with which the wave packet moves forward is what we call as group velocity. It's very simple. If there are large number of waves, all the large number of waves are traveling in the same direction, then all these large number of waves, they superpose on each other. Ella waves kuda ondra mele ondu superpose agutte. When they superpose, then there is a formation of wave packet, wave group, or it is called wave packet. And whatever the velocity with which that wave packet is traveling is what we call it as group velocity. Okay, group velocity is the velocity with which a group of wave travels, or group velocity is the velocity with which so a wave packet is traveling, and the wave packet yatara formation agutte, wave packet gets formed because of the superposition of large number of waves. When large number of waves are traveling together, they superpose with each other and they produce what we call it as wave packet. And whatever the velocity with which the wave packet is traveling is what we call it as group velocity. Okay, and the expression for group velocity is given by d omega by dk. The proof is then another next class al ಮಾಡ್ತೀನಿ. Expression for phase velocity is omega by k, but expression for group velocity is d omega by k. By omega by k ಅಂತ ಮಾಡ್ಕೊಂಡ್ರೆ phase velocity ಸಿಕ್ಬಿಡುತ್ತೆ, but omega ನ angular frequency ನ with respect to k differentiate ಮಾಡ್ಕೊಂಡ್ರೆ d omega by dk is equal to differentiation of omega with respect to k, then you will end up with so your group velocity. So how this comes? Vg is equal to d omega by dk yatara barutte, that I am going to prove in the next class. Okay, so please remember now. So group velocity is the velocity with which group of wave travels, or Group velocity is the velocity with which a wave packet traverses in a medium. Okay, ಗೊತ್ತಾಯ್ತಾ ಇದಿಷ್ಟು?